This is what prosthetics used to look like.
Prosthetics technology has gone from hooks like this to hands with limited motion like this.
So at the moment we have a prosthetic hand over here, and we also have some little sensors. These are called myoelectrodes, which is basically just a little sensor that measures your muscle activity.
So your brain can still give your muscles instructions,
Yeah.
but then those instructions are transferred to that,
Yes.
and that tells something like that what to do.
Yeah.
The idea is that I'm always ooh!
That's you. Yes, well done, you got the point. That's the
Yay.
hardest one, I think, trying to do them both. What I'm trying to do is design prosthetic sockets that facilitate that connection better. So how can we change the shape of this, or change the design of this, maybe change the materials, so that there's no disturbances happening. You're not getting, those electrodes moving around.
The race is on to get to net zero by 2050, but how are aeroplanes going to do that? Apparently one way is to improve blade design. I'm about to meet an expert who's going to explain all of this to me.
Here we have a rotor blade. This would be used in current designs for gas turbine jet engines.
That's nothing to do with the big fan blades that you see on the outside of an engine, right?
Is behind that big fan blade. Essentially here we can design the sort of three-dimensional blade profile and generate a file which is then ready to be machined into an actual blade like this one. Close the door and let the magic happen. This rig is actually called the Gibbons. It simulates a compressor that will be inside an actual gas turbine jet engine. What happens is the air goes inside, and then we get to take all the great measurements using these probes. So what we're doing here is some flow visualization. Now they're all spinning, and I'll put the wind tunnel on so we can get some air through. Definitely on the wind tunnel. Yeah. So it's really important that we're investigating new ways of propulsion, but also really improving current designs.
I've just got to NCAT laboratory at Loughborough University, where we're going to learn all about combustion engines.
I'm a combustion experimentalist as well, so I literally play with fire.
Which part of that engine are you concerned with?
So my part is right in the middle, it's right in the heart of the engine.
A sheet of laser light bounces off the fine mist of olive oil in the air as it leaves the fuel spray nozzle, and that all makes the fluid flow patterns visible.
When we've got this data, we run it through the algorithm and we create these vector maps. What we're looking at is the flow coming out of the fuel spray nozzles. You can see on here that the arrows are actually going back up into the fuel injector. And we can measure what pollutants we're getting. The artificial intelligence has been trained on how to operate the heater.
It's like a Star Wars spaceship.
Thank you very much.
Well, you know.
My beautiful assistant.
Do you know, you can smell burning metal.
The hot metal and fuel.
Kat's going to do it all over again together with the team.
Absolutely.
Yet more research, yet more data, and it's all towards just making better engines, right?
Better, more fuel efficient, more sustainable, more environmentally friendly engines that will take you on your holidays.
It is literally everywhere you turn. We use millions and millions of tons of it. I don't really think much about concrete, but I'm about to meet a civil engineer who is obsessed with it.
Take some of our cement here.
4.13.
Yeah.
So cement being weighed.
So I'm going to bring this off the scale because we know that's done. Keep going. It's hard work though, isn't it? And then
Much bigger pieces.
you put it straight into there. So that's the 10 mil.
So here are our ingredients.
Yep.
So time to blend.
The exciting part's where the magic happens.
This material that you use on a daily basis is like forming before your very eyes. It's
Yes.
a really weird sensation.
Okay, so we're going to pour in our cement. So we're going to stop here. We're going to leave these here for a day, and then when they harden a bit, set inside the moulds, they'll be taken out and put into the curing tank.
Here we go. But concrete is known to be really good in compression, right?
Yes, so that's why it's taking a lot of the weight.
I'm starting. Oh! That's quite an epic failure.
Yeah.
It's not like one little hairline
Hairline
crack. It does really show you
The makeup.
what's going on inside
Yeah.
and how the cement kind of went to the outside. The act of actually mixing these basic ingredients together and seeing it come to life as a material that is all around us. I can see why it's used so much and why Mimi is so obsessed with it, because it really is a wonder material. So I'm meeting someone called Chloe, who's a welder. She's got her very own container and I'm going to join her in there right now. I love this throne. Chloe the welder, this is definitely your container. I'm loving this. I can see why you're into welding. This is cool. All right. We're literally just trying to find bits of metal to weld together. We're going to turn it into a flower.
So that's because you've touched down and you stayed on there, it can spit back at you.
Ta-da!
Be proud? Good, so you should be, yeah.
Our final result. A rose on its stem, on a plate, with Chloe and my signature.
See, there's welding everywhere. I think they're spot welded. Oh, these will be TIG welded. It's going somewhere in public, you have to make sure that there's no sharp edges or anything like that. Like all these, that's all welded. I'm going to guess it's TIG welded.
Manufacturing is such an important part of engineering, and what Chloe is doing is so fundamental to that. And to think that she actually got into this industry all through an apprenticeship just adds to my total respect for her and the industry.